This problem deals with solving logarithmic equations, and the first thing we've got to see with this is that it is an equation. There's your equal sign right here. Log base 17 of this quantity equals log base 17 of this quantity. Don't let the big number 17 freak you out. Don't let any of that freak you out. My analogy for this has been if 3 squared equals 3 to the x, if the bases are the same and these two things are equal, then this exponent has to equal that exponent. Same thing is happening here. If log base 17 of that equals log base 17 of this, then that must equal this. I can just drop the logs and write my equation like so. It has to be true because the log and the base are the same. Therefore, what's in the parentheses on the right must equal the parentheses on the left. Okay, so now I can solve this and hope that it factors. If I bring that 18 over, it's going to become a plus 18v. I'm going to get a plus 77, but when I add 3 to both sides, I'm going to get an 80. And now I've got a quadratic. Let's hope it factors. If not, we'd have to do a quadratic formula, but let's try this out here. Okay, so I'm going to get a v here and a v here to get my v squared term. If these are plus plus, the signs here have to be plus plus. Now I'm looking for factors of 80 that will multiply to 80 and add to give me 18. So it could be 80 and 1, nope. Could be 40 and 2, nope. It could be, what's next? 20 and 4, not quite. Okay, so what's missing here? Are there other factors? That's a great question. Could be 10 and 8. Oh yeah, there we go. Add 10 and 8. And that's how that's going to work, because 10 times 8 is 80. 10v plus 8v will give me plus 18v. So here are my solutions. V is going to be equal to minus 10. If you remember, I take this part and put it equal to 0. So if this is 0, the whole thing is 0. And then when I do this, v plus 8 equals 0, I would get v equals minus 8, because when this piece is equal to 0, the whole thing is equal to 0. So each of these two independent sets of parentheses is how I find my solution or solutions. Okay, there's my two solutions for this equation, and that is it for that one.